Hello everyone. So we are continuing with our LeetCode solution series, and in this video we will understand this added distance problem. So this is one of the most commonly asked problems and it is also very important. So let's start. So given two strings word1 and word2, return the minimum number of operations required to convert word1 to word2. And there are three operations you can do. You can either insert a character anywhere, delete a character, or replace any character. And if you notice and you have to find the minimum number of operations. So it is like each operation has a fixed cost, which is one, which is like one operation. Now, for example, if the input is horse, word1 is horse and word2 is rose, ROS, then we need three operations to convert. So these are the three operations. Similarly, if this is the word and this is word2, they need four operations. So just quickly look at the length. So length is 500. So 500 of both words can be the length. So let's go to the whiteboard and see how we can solve it. So if I take the example, it is word1 is horse and your word2 was rose. Now, so this is horse and this is rose. So what we are doing is, so first operation is replace H with R. So you will get RORSE and ROS. Then the second operation is delete this R. And the third operation is delete this E. So finally you will get ROS and ROS. So hence we need three operations to convert horse to ROS. So this is the minimum. These are the minimum operations you require. If you try other operations, you will not get less than three. So how can we do it? Now it looks very difficult that there are so many ways I can remove any character, add any character. How do you know? Right, for example, let me give you a very simple example. Let's say your word1 is empty and word2 is AB. So what are the minimum operations to convert word1 to word2? It is very simple. Since this is empty, I have to add two numbers. So add A and B. So they are two operations. Similarly, if say word2 is empty, so you have to delete all the operations in word1. So these are the very basic things. But if you have input like this, how do you check all the permutations and combinations, that which to replace, which to delete? So we will not do that. What we will do, we will use a brute force approach here. For example, there are three options you can do at any point. When you are looking at H and R, since they are not equal, there are three ways I can do. Either I can delete H and move forward. So let me write all of these methods. So let's say you are at this and ROS. Since H and R is not equal, either you can delete the H. So what you can do, you can delete the H, and then what you will do, you will only compare ORSE with OS. Not OS, you will compare it with ROS. Because now you want to make ORSE equal to ROS because you have deleted H. So this is the one method you can do. Now what is the second method you can do? Since H and R is not equal, you can replace H. You can replace H with R because then RR becomes equal. And what you have to compare the rest of the strings is this. Then you have to make ORSE equals to OS because R and R has already become equal. So now this is the rest stuff we have to do. And what is the third operation? Third operation was we can add a new character. So which character you will add? Everyone has guessed it. We will add R. Now after adding R, what is the remaining part? So what you will do? you will make HORSE equals to OS because R and R are equal. Similarly, this. Okay. So at every point, now let's say you are at this point. So here also there are two methods. Since O and O are equal, you will move forward. Now you look at RS. Again, either you can add S, or you can delete R, or you can replace R with S. So again, at every point there are three operations you can perform. Okay, so let's say you are at index ij, you are at word1 I comma word2 j, you are at these two indexes. For example, you will start with 0 0, but it can change. Now from this, if they are not equal, so if word1 I is equals to word2 j, if they are equal, then we go to I plus 1 comma j plus 1 directly. Else, if they are not equal, there are three ways we can do. Either I can replace. If you replace, you will go to I plus 1 j plus 1 and the cost of replace, which is 1. If you notice here, when I was replacing, I am incrementing the index of word1 and word2 both. Now the second is you can add a character. So this is actually replace part. When you add a character, you do I comma j plus 1 plus 1. Adding. Here I am adding R. So I index will remain at H, but j index will go to O, will start from O because R is already matching now. So this case is when you add a new character. Or the third option is when you delete. So you go to I plus 1 comma j. What is delete? In this case you are deleting. So now you are going to I plus 1. This was I, this becomes I plus 1. And the word 2 is already at j. So this will not change. So this is the delete. So at every index ij pair of word 1 and word 2, there are three ways you can do. And you just want the minimum of this. You want the minimum of this. Out of all of these three values, they will return you something. They will return you the minimum operations needed. And after that, you will take the minimum of this and that will be your answer. So this is sort of a recursion. So let's write this code and see how we will do it. So I will write a function. So int min cost. So it will take int I, int j of word. It will take both the words as well. Okay. Now what we will do? If word 1 of I is equals to word 2 of j, we return min cost of I plus 1, j plus 1, word 1 and word 2. Else, what should we do? So either if I add, so if I add new character, what is the cost of that? It will be minimum cost of I comma j plus 1, word 1, word 2. Similarly, we can do it for delete cost. What is delete cost? It is I plus 1 and j. And finally, what is the replace cost? It is I plus 1 and j plus 1. And finally, what I want? I want the, and we have to add plus 1 as well here. and finally I want min of add cost, delete cost, and replace cost. Or I think we can pass it in this fashion as well. Okay, so and initially what we will ask here, we will say return min cost. The starting index for both words is 0 0, and word 1 and word 2. But now there are few things, right? We can see this is a recursive code, but then what is the base condition? What is the base condition here? If you notice, what if I is equals to word 1 dot size? It means that word 1 is empty now. We have reached till the end of word 1. So what is the remaining cost? If there is no element in the word 1, can I say it should be actually equals to word 2 dot size minus j. It means we have to add. So what are the remaining words in word 2? It is word 2 is at index j. So word 2 dot size minus j. These are the remaining elements in word 2. So remaining elements in word 2. What should we do with that? We will add all of those elements in the word 1. So the cost of doing that is this only. So that is why I'm directly returning it. There is one more case. What if j is equals to word 2 dot size? What if word 2 is empty? If word 2 is empty, we will return the size of remaining words in word 1. Remaining elements in word 1. If word 2 is empty and these are the remaining words in word 1, we will delete all of those elements so that they becomes equal to word 2. Okay, so let's see what do we mean by this. For example, we saw here, if word 1 is empty, we have to add these two elements in word 1. So it means if word 1 is empty, so and two elements are remaining in word 2, the 2 will be the answer. Similarly, if word 1 has AB and word 2 has empty, so we have to delete A and delete B to make it equal to word 2. That is why opposite. Now you can see if I directly write that code, it can give me TLE, right? Because right, we are going ij plus 1, I plus 1j. So there are roughly, for every min cost, there are 3 other min cost calls. So this is roughly an exponential solution, 3 raised to the power n. So, but we want a quadratic solution, n into m. So what we can do, here we can use the dp. So what we can do here, so for example, if you look here, 0 0. From index 0 0, either you can go to 1 1 if you replace, or 0 1 if you add, or 1 0 if you delete. From 1 1 you can go to 2 2, 1 2 and 2 1. From 0 1 you can go to 1 2, 2 3 and 1 1. Yes, so it is 1 2, 1 2, and this is not 2 3, this is actually 0 2. So now you can see there is an overlap here, 1 2 and 1 2 we are calculating 2 times, and similarly there will be a lot of overlaps. So for overlaps we can reduce them using dp. So now let's use dp here. So we will use that. So we will say int n is equals to and we will create a dp vector with all values initialized at -1, and we will pass this dp as well. So now in the input, let's take it. Okay, now here we will check if dp of ij is not equals to -1, then directly return dp of ij. Else we will first do dp of ij is equals to this min cost and then return. So we will populate dp of ij before returning it. And here also we will pass that dp. Okay, so let's run code. Let's see whether there is any compile errors. Okay, so yeah, here also we need to pass dp. Okay, now let's submit it. Okay, so this is correct. So now basically added distance is a very typical problem of a DP, and this is how we solve it. We don't try to be any smart. We just try to do all of these three operations and see which of them return the minimum cost, and we take that as the answer and we then pass it on. So in the end you will get the minimum cost to convert a string from 0 to n-1 and 0 to m-1. So convert whole word 1 to word 2. So if there is any doubt in this problem, because I know this problem is little difficult, ask me in the comments. If you like this question, please like this video, and I'm going to make a lot of LeetCode videos. So if you want to see those, you can subscribe to my channel as well. And I have a LeetCode playlist as well. You can check that out. It already has a lot of questions. So until the next video,